Good afternoon, and my name is Obundare. So I'm here to just analyze and explain the laws of indices. So what are indices, or what can we talk about indices to be? So let's say we have a base raised to power an exponent. So we can say indices or an index can be in this aspect. And for example, I can say 5 raised to power x. So where 5 is the base and x is the power. So 5 is the base and x is the power, which is representing the exponent. Now, talking about the laws of indices, how can we go about the laws of indices? First, let's talk about the additional law. Let's talk about the additional law. X raised to power a multiplied by x to the power of b. Now, in this aspect, for we to have the addition law, now we need to have the same base and the operation between them to be a multiple operation or multiplication operation. So if we have this case, then we can say that x to the power of a plus b. A typical example is 5 raised to power 2 multiplied by 5 raised to power 3. Now in this case, 5 as the base is actually common. So 5, we take one of it and we had the power. That's same thing as what? 5 raised to power 5. And 5 raised to power 5, that's 625 multiplied by 5. So that means that we can as well express this in 5 times 5 times 5 times 5 times 5. So that's 5 times 5, 25, 25 times 5, 125, 125 times 5, 625, and 625 times 5 also. So now we can as well do this. Let's assume they have coefficient. Let's say this example 1 and this example 2. Let's say, for example, they have coefficient 2y to the power of 4 multiplied by 5y to the power of 3. Now, this number is multiplying this variable, so that's why I call it its coefficient. 5 is multiplying this variable, that's why I call it its coefficient. Now, I can multiply the coefficient separate, and since the base are equal, take one of it, add the power. So that's 10y raised to power 7. And that is the final answer. And that's for the addition law. Let's talk about the subtraction law. Let's talk about the subtraction law. The subtraction law. Now, talking about the subtraction law, we have x to the power of a divided by x to the power of b. Now, if we have this case, now because division sign is in between, but the base are still the same, we take one of it and we say a minus b. Now, let's take for example, we have 5 times 10 raised to power 2 divided by 15 times 10 raised to power 2 divided by 3 times 10 raised to the power of 1. 3 times 10 raised to the power of 1. Now, 15 is a coefficient, 3 is a coefficient. So we say 15 divided by 3 straight, and we take one of this times 10 raised to power 2 minus 1. Because we said the power, we have to subtract it. Then the final answer here will now be what? 5 times 10 to the power of 1. And 10 to the power of 1 is still the same thing as 5 to the power of what? 5 times 10. Another example is this. Let's say we have 75. Let's say we have 75 y raised to power 2 z raised to power 4 divided by 5 y z squared. Now in this case, what we need to do is to divide the number separate and what? And do the indices law of division here, subtraction law rather. So 75 divided by 5. So y, this is power 2, and because this is actually the division side, so we can say 2 minus 1. So z 4 minus 2. Now this 75, 5 here 1, 5 here 1, and that's 15y z to the power of 2. That's the subtraction law. Now let's talk about the zero power law. The third one is talking about the zero power law. Now, talking about the zero power law. Now, any number to the power of 0, any number, any variable to the power of 0 will give us 1. Let's take, for example, we have 3 to the power of x multiplied by 3 to the power of minus x. Now, we know that the multiplication, this is the multiplication operation between these indices. Now, when we have this, we only take 1 and add the power. Now, I'm putting this in bracket because this have a negative power. Now, plus times minus will give us minus. So 3 raised power x minus x, that's 3 to the power of 0. And x minus x is 0. Anything to the power of 0 is what? 1. So that's to establish the zero power law. So the next one is to talk about what? The negative power law. So talk about the negative power law. Now, if we're talking about negative power law, that is, let's say x to the power of minus a. Now, whenever you have a number raised to the power of a negative number or negative variable, now you will take the inverse of the base so that the power that will be on the base now will be a positive power. The inverse of the base is like a multiplicative inverse of x now is 1 over x. Multiplicative inverse of y is 1 over y. So now 1 over x. Now the power on the base now will now be what? A positive power. Meaning we've been able to do away with the negative power. So for example, let's say we have 3 raised power minus 4. Now 3 raised power minus 4, that's 1 over 3 raised power 4. So 1 over 3 raised power 4 is 3 in 4 places, that's what? 81. So 1 over 81. So let's talk about fractional power law. Let's talk about fractional power. Fractional power law. Now, x to the power of 1 over a. Now, we are having a fraction in the power. We're having a fraction in the power. Now, 1 as the numerator. The numerator represents the power and the denominator represents the root. Now, how do we do this along the line? Now, this is, we said the numerator represents the root. That's a root. The base will be inside the square, inside the root, and all to the power of what? To the power of 1. That's why I said the numerator will represent the power. A typical example is 8 to the power of what? 2 over 3. Now, 8 to the power of 2 over 3. 2 is the power and 3 is the root. So meaning we have cube root of 8 all raised power 2. Now, cube root of 8, that is, we need to think of a number that whenever we multiply 3 times, that same number, when we multiply it 3 times, it will give us 8. And the simplest number that can give us 8, multiplying it 3 times is 2. Because if you try 1 times 1 times 1 is still 1. But if you try 2 times 2 times 2 is actually 8. So that's what? 2 raised power 2. And the final answer here is what? Is 4. That's to talk about the fractional power law. Now, let's talk about bringing the negative power law and the fractional power together. So now the next, we are bringing negative fractional power. Negative fractional power. Now, let's say we have x to the power of minus a over b. Now, x to the power of minus a over b. Now, a is the power and b is the root, as earlier stated here. Now, but it's having a negative. Now, for the negative to disappear, we just need to take the inverse of the base and add a positive power. So that's 1 over x to the power of a over b. And going forward, we can say it is what? 1 over root b root x all to the power of what? A. So that is the by implication. And now we can now say that let's have an example of the negative fractional power. Let's take, for example, we have 27 over 8 all raised to the power of what? Minus 2 over 3. All raised to the power minus 2 over 3. Now this is a fraction with a fractional power. Now what the negative sign needs to do there is just to do a flip. It's just to do the inverse. Now, how do we achieve the inverse? Now, for we to have an inverse of this, now 8 will represent the numerator and 27 will represent what? The denominator, of which the power now will now be 2 over 3 because we've done the inverse. So automatically there's no negative sign again. So now we said the cube root of 8 over 27 all square. The cube root of 8 over 27 all square. Now, we know earlier that the cube root of 8 is 2. We know earlier that the cube root of 8 is 2. And the cube root of 27 is 3. All raised power 2. And that is what? 2 raised power 2, that's 4. 3 raised power 2, that's what? That's 9. So the final answer is what? 4 over 9. And another example that we can talk about here is, let's assume we have, example 3, let's assume we have 0.027 raised power minus 2 over 3. Now, this is a decimal fraction. It's actually different from the normal one we're talking about. Now, how do we convert the decimal fraction to a fraction? The decimal to fraction now. Now, 0 point. Now, 0 point. This will represent the point. Decimal point will represent 1, and this 1, 2, 3 will represent 0. So that's what? 27 over 1000 all raised power minus 2 over 3. Now for the minus to go away, 1000 will be the denominator, 27 will be the numerator, so 2 over 3. Then we can say the cube root of 1000 over 27 all raised power what? 2. What's the cube root of 1000? That's 10. What's the cube root of 27? That's 3. All square. So the final answer there will now be 10 squared over 3 squared. And the final answer will now be what? Will be 100 over 9. Since this video is actually a 15-minute video, then we can actually talk about other laws. But basically, these are the major laws except the last law, which is the multiplication of power. And multiplication of power, let's say we have x raised power a, x raised all raised power b. So this implies that we say x raised power a times b. And a typical example, let's say we have 5 raised power 2 all raised power 3. So that's 5 raised power what? 5 raised power 2 times 3. And that's what? 5 raised power 6. So 5 to the power of 6. So that's exactly about the laws of indices. Thank you.